Good morning, student. I am Mr. Gundar Chowgule. Today we have to discuss the single-phase induction motor. What is the working principle? What is the construction? And what are the different types? We have to discuss here. In that, we have to discuss first here single-phase induction motor. The single-phase induction motor, it will be mainly consist of two parts, that is stator and a rotor. The stator is the stationary part of the machine and the rotor is the rotating part of the machine. The rotor, it will be consist of copper or aluminum material, and see at the center we have to show the rotor, and at the middle there will be shaft is present, and on that shaft there will be rotor is present, and the rotor is rotating part of the machine, and the stator is the stationary part of the machine. And see here, this is the stator winding, and the stator winding is having single phase because the motor is single phase induction motor. And for the operation of the single phase induction motor, it requires the AC supply for the operation. Why the name of this motor is single phase induction motor? Because for the operation of this motor, it requires the single phase AC supply, and it will be works on the principle of induction, Faraday's law of electromagnetic induction principle. Then what is the Faraday's law of electromagnetic induction principle? According to the Faraday's law of electromagnetic induction, whenever the current, any conductor is rotating in the magnetic field, the EMF is induced in the magnetic field. EMF is induced in the conductor. This is the Faraday's law, and according to the Faraday's law, whatever the EMF induced in the conductor, it will be given by 1 minute. According to the Faraday's law, EMF, it will be given by minus N into d phi upon dt. That will be the Faraday's law. And according to that induction principle, the single phase induction motor, it will be works. Then we are already discussed what is the stator, and it will be consist of laminated steels, laminated construction, and in that there will be number of slots are present, and inside that slots we have to keeping the stator winding or stator conductors, and to the stator conductors we have to giving the AC supply. And in the rotor, we have to discuss there will be two types of rotors, that is squirrel cage induction rotor and the slip ring induction rotor. In the squirrel cage induction rotor, there will be long copper bars are present or aluminum bars are present, and that aluminum bars are welded with the end ring. That end ring having same material as the copper bars or aluminum bars. Suppose we have to use the here copper bars, then end ring material is copper. Suppose we have to use the aluminum bars, then the material of the end ring is aluminum. Okay, this is the material used for the rotor. And see the structure. These copper bars are welded at the both the ends. See here, there will be one welding ring is present, and on the other end there will be again end ring is present. So see the structure of this rotor. It will be look like as a cage. So the name of the rotor is squirrel cage induction rotor. Then there will be next rotor type is slip ring rotor. In that slip ring rotor, see this is the shaft of the rotor, and on the shaft of the rotor there will be slip rings are present, 1, 2, 3. These slip rings are present on the shaft. So because of the use of the slip ring in the rotor, so it is name is slip ring rotor. And see at the bottom of the each slip ring we have to provided the brushes, and to the brushes we have to connected the resistances. What is the use of that external resistance connected in series with the slip ring is, the use is to extend or to increase the starting resistance of the motor. So we have to use the external resistance here. and see this is the three-phase rotor, and each rotor it will be each winding of the rotor it will be connected to the each slip ring. See the R phase it will be connected to one slip ring, Y phase it will be connected to the second slip ring, and B phase it will be connected to the third slip ring. Okay, this is the structure is used to increase the starting torque of the rotor or motor. Then there will be different types of single phase induction motors are present. In that there will be split phase induction motor, capacitor start induction motor, permanent capacitor induction motor, capacitor start, capacitor run induction motor, shaded pole. These are the five types of the single phase induction motor. In that we have to discuss here what is the slip ring split phase induction motor. In the split phase induction motor means the starting winding it will be connected or it will be splitted into two parts, that is starting winding and main winding. The starting winding it will be connected to the centrifugal switch, okay, and the starting winding is having resistive in nature, okay, and the main winding is inductive in nature. These natures are very important whenever we have to design the starting winding and main winding. Okay, suppose V is the applied voltage across the motor and I is the total current flowing through the motor. It will be divided into two parts. Okay, Im is the current through the main winding and Ist is the current flowing through the starting winding. And see, in series with the starting winding, we have to connect it the centrifugal switch. And see here, there will be one rotor, that is squirrel cage type of rotor is used. And see here, there will be a phasor diagram is shown. V is the reference voltage. It will be applied across the motor. And see, the starting winding is resistive in nature. So, the starting winding current is nearly in phase with the voltage. And main winding is inductive in nature, highly inductive in nature. Because of that, current through the main winding is lagging with the voltage by 90 degree. Okay, then once the voltage is applied across the motor, this centrifugal switch is closed, and whenever the current is flowing through that starting winding, current is flowing through the starting winding and main winding. The main purpose of this structure is to produce the rotating magnetic field in the motor. Once the rotating magnetic field is produced, the rotor is started or the single phase induction motor is self started. But see here, the single phase induction motor is not self started, means whenever the supply is given to the motor is not started. In order to make the single phase induction motor self starting, we have to make the changes in the starting stator winding. That is, stator winding is split into two parts. In order to produce the rotating magnetic field, we require the at least minimum two fluxes, that is two rotating fields, and the angle between the rotating magnetic field is 90 degree. That will be very, very important. So in order to make that changes, we have to split the stator winding into two parts, that is starting winding and main winding. Because of this structure, there will be producing the rotating magnetic field and the rotor will be starts rotating. And whenever the motor is or the rotor speed is reaches 75 to 80% of the synchronous speed, the centrifugal switch is opens automatically, and this starting winding is goes out of the circuit and the rotor is continuously run with the help of main winding. Okay, that will be the working principle of split phase induction motor. Then the second one is the capacitor start single phase induction motor. In that, why the name is capacitor start? Because for the starting purpose we have to use the capacitor. That will be the case. And see here, the stator winding it will be splitted into two parts, that is main winding and starting winding. Current flowing through the main winding is Im and current flowing through the starting winding is Ist. And see here, capacitor it is connected in series with the starting